We've got a graph of f of x, and now we're going to start putting both the stretches, horizontal and vertical, together. So when we see this 4, it's outside of the function. That's going to be a vertical stretch. I'm going to use the abbreviations vertical stretch. And a little note underneath, that would mean I'm going to multiply my y value by 4. On the inside, I have a negative 1/2. Well, the negative is a horizontal reflection, and the half would be a horizontal stretch. Why? Because you're going to multiply your x value by negative. Half is 1 over 2. The reciprocal would be 2 over 1. So we multiply x by negative 2. And once you start to get to these ones that have more than one thing, it's not just easy to just do it on the graph. And so the strategy that I've showed you before that we're going to use here is we're going to label some points on the original one. So we have negative 2, 0. I have negative 1, 1. Maybe I'll do one more point. 2, 2. And then I'm going to draw arrows here to show those points are changing. And above those arrows, I'm going to say what's going to happen. So for example, we already wrote down that we need to multiply y by 4 and x by a negative 2. And we're going to see where these points go. So the first one, negative 2, 0, that one's going to become positive 4, 0. Negative 1 times negative 2 would be positive 2. 1 times 4, 2, 4. And 2, 2 will become negative 4, 8. So now I can label those points 4, 0, 2, 4, and negative 4. Oh, this is a little bit, oh, that's really off my graph, but that's okay. Negative 4, 8. And now I have 3 points. But that still doesn't completely tell me what is my graph going to look like. Because sometimes you have 3 points and you're kind of like, I'm not quite sure. So a couple of things. First of all, can you see that this is the starting point? That's a key point. That's this one right here. Where does it go? It goes to 4, 0. Oh, so that's my starting point. And if I know that's my starting point, maybe this makes sense to draw it that way. Second thing you can do is sort of a check, sort of a mental math check. Think about what we wrote. We've got a vertical stretch that's going to pull it away from the x-axis. A horizontal reflection. Can you see that the blue one's been reflected over the y-axis? It's now going the opposite direction. So now that also sort of confirms that I like the way my graph is looking. I also need a horizontal stretch which pulls it out this way. Okay? Sometimes the stretches and compressions are hard to see. Did I do enough or not? Because it's hard to visualize that. But definitely you can see the reflection and that my shape should look like this. Right? You could, this would be a bad idea, straight lines. Because there was no straight lines between points in the original one. So we want to have the shape matching up, that key starting point to recognize which one that was. That would also help. Okay? Again, it asks for domain and range for each of these. Did I use set notation last time? So interval notation this time. The smallest value is negative 2 and goes up forever. For the range, the smallest value is 0 and goes up forever. On the blue graph, there is no smallest value. So now it starts at negative infinity, but there's a largest value at 4, and the range stayed the same. And I'm going to add a part B to this question. write the explicit equation for y equals f of x and y equals 4f of negative 0.5x. So the question was given to us in function notation, where you had a function on the right-hand side, y equals f of x. However, if you look at that graph, can you recognize that it's one of the functions that we did at the beginning on those pages, on those 4 colored pages? Which one is it? What shape is it? And it's not only that shape, but it's already been moved. What graph had that curve like that? The square root graph. And the square root graph started at 0, 0. So can you see that the red square root graph has been moved 2 to the left? How would I write that as an equation? And I'll write it in red here. Y equals square root, the 2 to the left would be inside the function, x plus 2. And that was the function we started with. So we could either say y equals that, or that's the function we started with. F of x is the square root of x plus 2. Now we want to write this equation, the blue one. Well, it's going to be y equals, that 4 is outside the function, so it would still be 4. And how does function notation work? Well, whatever you plug into the function replaces the x. So my function was the square root of x plus 2. And now I'm going to plug in a negative 0.05x, where the x is, and there would still be plus 2 afterwards. So one of the things that's sometimes difficult in this class is that idea of switching from function notation to an explicit equation. So one of the things that I'm trying to do here is when I see an opportunity where we can go back and forth, to give you some more practice with that. Okay, questions 7, 9, and 10.